Hi everybody, welcome back to the channel. This is going to be our third video in our series of benzene videos, and y'all are in for a treat because this one is going to be really short. So in the last two videos, we looked at the reactions coming directly off of the benzene. Again, these reactions fall into a category of reactions called electrophilic aromatic substitution reactions. And in these reactions, we substituted a benzene hydrogen for a halogen, nitro group, acyl group, or sulfur group. In today's video, we're going to look at how we can convert some of these groups that we added to our benzene into some other type of group. And the category of reactions that these reactions fall into are known as oxidation and reduction reactions. So let's start off by looking at how we can use oxidation and reduction reactions to interconvert between a nitro group and an amino group. To convert the nitro group on a benzene into an amino group, you're going to want to use tin and hydrochloric acid. To convert an amino group on a benzene into a nitro group, you can use any peroxy acid, but the one that is probably most common and familiar to you is MCPBA. So when we convert a nitro group into an amino group, the nitro group is becoming reduced. And there's an easy way you can tell if something is being reduced or oxidized. If you see that there are fewer bonds to oxygen and or more bonds to hydrogen, then what you're looking at is being reduced. So this nitrogen here starts off with a few bonds to oxygen. After the reaction, the nitrogen has no bonds to oxygen. And as we just said, reducing the number of bonds to oxygen indicates that you're being reduced. So going from a few bonds to 0 bonds to oxygen is indicating that the nitro group is being reduced. Now when we convert an amino group into a nitro group, the amino group is being oxidized. Oxidation is the opposite of reduction. So if you see more bonds to oxygen and or fewer bonds to hydrogen, then what you're looking at is being oxidized. As you can see, we started out with no bonds to oxygen and ended up with a few bonds to oxygen. This is telling us that the amino group is being oxidized. So we just looked at how we can convert a nitro group into an amino group and vice versa. Now we're going to look at how we can convert our acyl group into an alkyl group. We can get rid of the carbonyl in our acyl group to give us an alkyl group by performing a reaction called Clemmensen reduction. And the ingredients you'll need to do this are a zinc-mercury complex and hydrochloric acid. Now there's one thing I like to point out. When we converted our nitro group into an amino group, we used tin. Here we're using a zinc-mercury complex. Tin is a weak reducing agent, so if you use tin here instead of the zinc-mercury complex, it would not reduce the acyl group. However, the zinc-mercury complex is a stronger reducing agent and will also reduce a nitro group into an amino group. This is going to become an important thing to know when we start looking at benzenes with more than one group on it. And that's a wrap on our benzene tree. Woohoo! Y'all are doing so great. Keep up the good work and feel free to comment below any questions or suggestions you have.